My honours project is the unique acoustic identifiers in frog calls and how they can be used to distinguish species. My project investigates frog calls within a natural habitat. The reason why I am focusing on frog calls is because they are largely understudied. Mainly because frogs are shy in nature and they will flee into water bodies or hide in burrows when they are confronted. To combat this, passive acoustic monitoring is now being used to analyze these organisms. Passive acoustic monitoring is a process where you place a recording device in the environment and leave it over a period of time to record the animal calls. This process is becoming more popular as it is a non-invasive procedure which does not harm the animal or the environment. Passive acoustic monitoring results in large and continuous datasets with background noises such as cars and planes, so it is difficult to find our target organisms within these audio files. So there is a need to come up with a method to identify our target organisms. One such method is to use the unique acoustic identifiers of their calls. Ideally, this should be done through machine learning as it would be easier and quicker. The software that I'll be using to analyze and edit these files are R, Audacity, and BatSound. The parameters that I will be measuring are the lengths and periods of the frog calls and their syllables. Then I'll be measuring their frequencies. To analyze these files, I will first use a cluster analysis to produce my groupings that I will then critically identify through a discriminant function analysis. The parameters will mostly be measured automatically using R packages TuneR and CWave. This can be made possible through Hilbert's amplitude envelopes, which can be seen on the top left and bottom right. Measurements can also be done manually if difficulties arise. However, there may be uncertainties due to the background noises within the calls. The cluster analysis will help group my unknown calls to prior identified calls. The discriminant function analysis will then compare these two and distinguish the species of the unknown call. A confusion matrix can then be used to determine the accuracy of the results. At the end of the study, I hope to successfully identify frog species, provide a rich dataset for further analysis, and hasten the identification procedure. Thank you.